Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel where we talk about everything I want to, science and math. And what we're doing now is we are going through this book, Addison Wesley Chemistry, and we're going to talk about, I've made 2 videos talking about Chapter 17, Properties of Solutions. Look how fun that is. And now we're going to talk about the math. So I've turned the camera around. And we're going to go through. Look, there's our sweet iced tea. This got glare on. Adding the sugar to it. Okay, and there is they're adding just a few crystals to the supersaturated solution. And it goes. I bet you can see a very good video of that on YouTube. All right, so here's example problem number 1. It says, if the solubility of a gas in water is 0.77 grams per liter at 350 kilopascals, remember the pressure affects the solubility of a gas, what is the solubility in grams per liter at 100 kilopascals of pressure? The temperature is held constant at 25. So this is simply a cross multiply solve for x. 0.77 is to 350 as x is to 100. Do 0.77 times 100 and then divide by 350. X equals 22.22 grams per liter. So that's easy. All right, there's your lab you're going to be doing with colloids. Okay, here's your next problem. A saline solution contains 0.9 grams of sodium chloride, that's table salt, per 100 milliliters of solution. What is its molarity? So molarity is grams per liter, and we have grams per milliliters. So first of all, we need to know the molar mass of sodium chloride. So we look on the periodic table, we look at sodium, and we see that its mass is 22.9 something. So we're going to round that to 23. And chlorine is 35.45. So we're going to round that to 35.5. We add them together, and that's the molar mass of sodium chloride. That's how many, that's 1 mole. And if you put that 58.5 grams into 1 liter, you'd have a 1 molar solution. Okay, so the next thing we need to do is we want to change our grams to moles. So we start with our 90 grams that we had, we divide it by the molar mass, and then we have the moles, or 0.015 moles, okay? We have milliliters, and we need it to become liters. And we can use our King Henry's Daughter Bakes Delicious Chocolate Muffins frog hop method. To go from milli to basic, it's 3 frog hops. So our decimal point moves 3 times, and our liters instead are now 0.1 liter. From 100 milliliters, 1, 2, 3, 1.1 liter. So we have our molarity is moles per liter, and our molarity, we got our moles here and our liters there, we divide them, and our molarity is 0.15 moles, molarity solution. And this would be a capital M. Lowercase m is molality. All right, example 3. How many grams of solute are present in 1.5 liters of a 0.2 molar sodium carbonate? Sulfate. There's a glare here. I wasn't reading it right. All right. So here we want to know how many grams is in 1.5 liters of 0.2 molar. And that's our chemical. And so we're going to look up the molar mass. So we do sodium times 2 plus sulfur plus oxygen times 4, and it's 142.1 grams per mole. So the molarity is moles per liter, and so 0.2 equals the moles over 1.5. Multiply by 1.5, multiply by 1.5, and it is 0.3. Now we can change this into grams by our 0.3 divided by 1, because it's gram per moles, and we want moles on bottom because we want them to cancel out, times 142.1 grams, and we end up with how many grams that would be. And they rounded it off to 43 for 2 significant figures. All right. Example problem number 4. It is you have the M's and V's, and you'll be given 3 out of the 4, and you just solve it algebraically. So how would you prepare 100 milliliters, right there, that's our volume, of 0.4 molar, right there, from a stock of 2. So we multiply those together, then divide by 2, and it's 20. There's no unit needed because it's a ratio. Okay. We don't have to worry about the ratio, the unit changes there. All right, example 5 is calculating percent by volume. So they tell us it's 75 milliliters in 250 milliliters, so that would be 30%. Let's turn that so you can see it a little bit better. So that's a pretty simple one. This example 6, skip it. This is very rarely done, so we're not going to bother with that. Here's our colligative properties. You can tell it has more solute particles that are not volatile. If you add that, it makes it where there's less that evaporates to be above it. It's sort of like it's getting in the way of these particles getting to the surface so they can get out and evaporate. So there's your molality, moles of solute over kilograms. Okay, using solution molality. So here's a problem of it where they took the X is your number of grams, and that's 0.5 kilograms. The solvent is 100 grams of water. The molality is 0.06. So you do molality equals X over 0.5. Solve for X, it's 0.3. Multiply it times your gram formula mass to get that you're getting here, which is 39 plus 126.9, and then that tells you your grams of potassium iodine is 4.98. They rounded it off to 5 because of sig figs. Mole fraction, that's really some more algebra 2. Algebra 2, I keep saying that. Chem 2 also, but if you want to see how I do it, there's my work. All right. Let's see if there's anything else that you need to do. Calculating the boiling point elevation of a solution, same thing, more of a Chem 2 thing, but if you're interested in doing it, there's my work. Take a look at it. You can freeze that, go in, and you can see it better. And same thing with example 10. Don't worry about those. But if you want to, feel free. Figure it out. All right, come back next time and we will talk about reaction rates and equilibrium. Like, share, subscribe. Science is great.